Okay, right now in question 2, they want us to prove that triangle, ne? They want us to prove that triangle G O, sorry. So they want us to prove that triangle G O N is similar to triangle, let me use a different color, blue, to triangle G H E. Okay, so they want us to prove those two triangles to actually be similar to each other. Now remember, to be able to prove those two triangles to be similar, we need to know what's basically going to be their angles. All right, now to find those angles, first we're gonna do this. So in triangle, so first of all, I'm gonna say in triangle GON, I have that angle O, or I have that angle GON is equals to 2x, and that is given, right? Now to find the other angles, I need to find angle OGN and angle ONG. But remember that GO is equals to ON because of riding. So basically, for me to find the angle, so basically it means that angle OGN is going to be equals to angle ONG, right? And the reason for that is going to be GO equals to ON, or isosceles triangle. All right, so for me to find those two angles now, I can just basically say that it's gonna be to find, let's just say I wanted to find angle GOGN, so I'm gonna say sorry, so I'm gonna say that 2 times angle OGN is going to be equals to 180 degrees minus angle GON, right? Then I'm going to say interior angles of a triangle, right? So it will be 2 times OGN equals to 180 degrees minus 2x. Then I'm going to divide both sides by 2. And if I do that, OGN, right, is equals to ONG, right, which is going to be equals to 90 degrees minus x, right? So we now found that the angles in triangle GON is going to be 2x, and the other ones are going to be 90 degrees minus x. All right, now using a different color, so now I'm going to say that in triangle GHE. All right, now in triangle GHE, we are given that GH and HE is equals to each other as given in the question. So we are told that, HG and HE, we are told that HG equals to HE, which is given, right? So basically, angle HGE, so angle HGE is going to be equals to HEG. HEG, and the property is going to be HG equals to HE isosceles triangle. All right, so we now know that angle HGE and HG is going to be equals to each other. So the angle that we're actually looking for is going to be angle GHE, right, which is actually H2. So to find that angle angle GHE or angle H2, we're gonna need to actually know what is the angle here. So we're gonna need to know what is the angle of N1 plus N2, and then we're gonna use the property of interior angles of a cyclic quad. Interior opposite angles of a cyclic quad are equals to 180 degrees exactly. So you're gonna need to find that angle there to know what is that angle over there. Right now, to find that angle, we basically just gonna say to use it. Let me show you how, using a different color. So to find that angle, I'm gonna first say that angle G. I'm gonna say that angle GNE, right? Angle GNE, right, is gonna be equal to 180 degrees minus angle G1 minus angle E2, right? Then I'm gonna say interior angles of triangle G and E, right? So that angle is actually just 180 minus, because G1 and E2, they're both x, so it's just 180 minus 2x. All right, now to find the angle H2 now, so now I'm gonna say that G and E plus GHE, right, must give me 180 degrees. And the reason for that is going to be opposite interior angles of a cyclic quad, right? So to find GHE, I'm going to basically just say GHE is basically just 180 degrees minus G and E, right? Now remember, G and E, we calculated it to be 180 minus 2x, which is basically just gonna be 2x. So we now know that angle GHE is gonna be 2x. Now to find the other angles, now we're gonna just say, switch to blue. So I'm now gonna say that angle, I'm gonna just say 2 times HGE, right, is gonna be equals to 180 degrees minus GHE, interior angles of a triangle, right? So that is going to be 2HGE equals to 180 degrees minus 2x, right? And then I'm going to divide both sides by 2, dividing both sides by 2. Therefore, HGE is going to be equals to HEG, which is also just going to be equals to 90 minus x. Okay, so now we know everything that's happening there. Now to do that, so now I'm going to say that in triangle GON and triangle GHE, right, we have that angle GON. So GON is equals to GHE, right? It's going to be equals to GHE, right, which is both equals to 2x, and then angle GON. Now I'm gonna go to angle, where's those other angles? So OGN is gonna be equals to OGN is gonna be equals to HGE, right? I'm just gonna say HGE, and also angle ONG also equals to angle HEG, right? Both equals to 90 minus x, both equals to 90 degrees minus x. Then therefore triangle GON is similar to triangle GHE. Then that reason is gonna be angle, right? So it's gonna be angle, and then yeah, this is how you can basically prove that those two triangles are actually similar to each other. Okay.